Okay, welcome to part 3 of the factoring videos here. This one we're going to talk about trinomial factoring, but this time with non-1 leading coefficients. If you haven't recently watched part 2, you should watch that again to revisit that, because this is just a slight change in that procedure. Okay, the only difference is that this time we're talking about trinomials that have something other than a 1 here for this first term, like a 2x squared or a negative 3x squared or something like that. Okay, so the modification is basically that we're going to first we're going to look to see if there's a greatest common factor, because often we can factor that leading term out. And if that doesn't work, there's another step. Okay, so in this case, I have a 2x squared, I have a plus 12x, and I have a 16, and those are all, the number portions are all divisible by 2. So using the greatest common factor factoring method, we could factor a 2 out. So I'm going to do that. I'm going to factor a 2 out, and what will be left behind is an x squared plus a 6x plus an 8. Okay, then what I'm going to do is I'm going to just sort of leave the 2 over here on the side, and I'm going to work with the rest of the trinomial, which now has a leading coefficient of 1. So I would do my normal factoring, where I make a t-chart, and I multiply and add to a particular number, the two numbers that are going to go on the factors here, like this. And I still have that 2, so I don't want to forget to copy that down. But I'm looking for these two numbers. Okay, so those two numbers have to multiply to the outside numbers, which is 1 times 8, and they have to add to the middle number, which is 6. So ways to get 8. 1 times 8, negative 1 times negative 8. 2 times 4, negative 2 times negative 4. Okay, let's see, if I add those I get 9, negative 9, 6, negative 6, and 6 is the right answer, so 2 and 4 are the two numbers. So I'd have plus 2 and plus 4. So let me just write it over again. Here is the original expression, but factored completely. I have the two binomials that I was able to factor because I first factored out a 2. So really there are three factors here. There's the 2, there's the x plus 2, and the x plus 4. If we wanted to check it, we should probably do this part first. Let's multiply those two things together, and then we'll multiply the result by the 2. So I'm going to turn it back into a big expression here. X times x is x squared. X times 4 is 4x, plus 2x plus 8, combining like terms, x squared plus 6x plus 8. And then when I distribute the 2, I'll have 2x squared plus 12x plus 16, and that is the original expression, which means this is fully factored. So sometimes you can handle that leading coefficient, if it isn't a 1, just by finding a greatest common factor. But that doesn't always work. In this case, there's a leading 2, but there is no 2. The middle term is negative 1 for its coefficient, so we can't factor out a great common factor. Okay, in this case, what we do is something almost the same. We go ahead and proceed. We have the two numbers multiply and add to different numbers. Okay, but we've been saying all along that the two numbers multiply to the first number times the last number, which is a 2 times a negative 6. So that means the numbers that we're looking for have to multiply to a negative 12. And those same numbers add to the negative 1. So I look for this and I say, all right, I need a negative 12. I can get that with a 1 times a negative 12, or a negative 1 times a positive 12, or a 2 times a negative 6, or a negative 2 times a 6, or a 3 times a negative 4, and a negative 3 times a positive 4. And the one that's going to add up to negative 1 is this one right here, right? Positive 3 plus negative 4 does add up to negative 1. So the numbers are 3 and negative 4. Now, this is the one change to the procedure if you have something that's not a 1 in this location. Okay, when we do the terms, when we make the factors, we used to copy an x here, here and here, right? But what we're going to do instead is we're going to go ahead and copy the 2 along with the x. And we'll put that 2 in both places. So this leading 2 is going to get copied to both along with the x. Okay? But when I insert my numbers, plus 3 and minus 4, because I had to copy a 2, I'm going to divide both factors by whatever number is in common to the two coefficients. Here's what I mean. Let's say on the right side, right, on this factor here, I have a 2 and I have a negative 4. The number 2 goes into both of those evenly. And so if I were to divide that 2 out, I'm going to get just an x on this side. That's important because if I didn't do that division, it would be 2x times 2x, which would be 4 x squared, and we only have 2x squared, so we can't have a 2 in both places, but I don't really know at first which one needs to go away. Now on the left factor I have a 2 and a 3, and 1 is the only number that goes into both of those. So on the left factor, this stays 2x plus 3 divided by 1, so it remains 2x plus 3. But on the right factor, 2x divided by 2 is just 1x, and negative 4 divided by 2 is negative 2. And so that's the factorization. So the change to the procedure from the second video is that you just copy the 2, and then you divide out any common factors within each factor. Okay, let's double check though. We should always do that, especially when we have these more complicated cases. So everything in here multiplied by 2x first is 2x squared minus 4x, and then everything multiplied by the 3 would be positive 3x minus 6. Combining like terms, 2x squared minus 1x minus 6. And that is the original expression, so that is factored correctly. All right, here's another example. Try to pause the video and see if you can do this. Okay, we would look and say there's no greatest common factor here. We can't take the 3 out because it won't divide evenly out of the 8. Okay, not without creating a fraction, which that would not help us solve the problem. So instead, we're going to just go ahead and proceed with the normal multiply add. But the multiply is 3 times negative 3, so negative 9 is what the two numbers need to multiply to, and they need to add to a negative 8. So how can I get a negative 9? 1 times negative 9, or negative 1 times positive 9, or 3 times negative 3, and that would cover it, right? All right, so what do these add to? This 1 plus negative 9 gives me negative 8, negative 1 plus 9 gives me 8, and 3 plus negative 3 gives me 0. So it looks like negative 8 is right, and the numbers are 1 and negative 9. Okay, but because I have the leading 3, I'm going to copy that 3 along with the x. When I build my factors, I'll plug in the positive 1 and the negative 9, but I'll remember, because I copied a 3, that I might have to divide it out. So on the left side, 3 and 1 are only divisible by 1, but 3 and negative 9 are divisible by 3. So the left factor remains 3x plus 1, but the right factor becomes 3x divided by 3, which is x, and negative 9 divided by 3, which is negative 3. So that is the answer, and we should check. Let's check it by distribution. Everything in here times 3x, 3x squared. Negative 3 times 3x would be negative 9x, and then everything in here times 1, so plus x minus 3. Combining like terms, 3x squared minus 8x minus 3, and that is the original expression, so we are factored correctly. All right, one more example. We have 6x squared plus 3x minus 3. Pause the video, try this. Okay, welcome back. So actually, it looks like we might be able to take a common factor out here. Maybe I could take a 3 out. It looks like a 3 could come out. Let's do that first. Let's pull a 3 out. Then I would be left with 2x squared plus x minus 1, right? If I factored out that greatest common factor of a 3. So that helped me a little bit. It made the trinomial a little smaller numbers, but I'm still going to have to do this kind of factoring with copying the 2x eventually. So now I would have 2 times negative 1, which is negative 2, that the two numbers multiply to, and they multiply to that middle term coefficient, which is 1. To get a negative 2, I'm going to have 1 times a negative 2, or a negative 1 times a 2. So the top one adds to negative 1, and the bottom adds to positive 1, so it looks like my two numbers are negative 1 and 2. I've got my 3 still out here. I don't want to forget. At first, I copy the 2x to both factors, then I insert the negative 1 and the positive 2, but because I copied the 2 to both places, I've got to divide out any common factors, and the one on the right is both divisible by 2, so I'm left with this as the final answer, because 2x divided by 2 is x, and 2 divided by 2 is 1. We should definitely check this one. Let's do that over here. 3 times 2x minus 1 times x plus 1. First we'll do this part, and I'll leave the 3 out here. So I have 2x squared plus 2x minus x minus 1. That's 3 times 2x squared. 2x minus x is 1x. And then if I distribute that 3 times 2 is 6x squared plus 3x minus 3. And that is, in fact, the original expression. So we're good. Okay, that's all there is to that procedure. Like I said, it's just a variation of the procedure that we learned in part 2. When you're done with this, try your hand at the problems in the practice pages, and then move on to the next video when you're ready.